first thing, theory of evolution, the kind of standard story. So don't worry about if I've kind of like overgeneralized or what, because my idea, my goal here is not to actually teach anybody evolution here. Okay, but just to give some outline sketches. So these are broad strokes. Generally, when people talk about evolution, when science talks about evolution, it's referring to the way that living things change or evolve over long periods of time. Normally, evolution is to do with the way things change or evolve over time. Those things may be plants, those things may be fish, right? Those things may be humans, okay? But it's about living things evolve. Primarily, it's about living things evolving. So it's less about plants, living things evolving over long periods of time. By long periods, I'm not talking about a human lifetime. I'm not talking about even the lifetime of an empire, 400, 500 years or whatever. We're talking about tens of thousands or hundreds of thousands of years, those kind of time scales, those kind of almost cosmic time scales. The second thing, evolution when it talks about changes, how living things change, we're talking about change primarily at the genetic level, at the levels of genes and DNA, through, according to how we're taught it, genes adapting or mutating, okay? And these changes in genes, okay, they're passed on or inherited from one generation of species to the next. And that's where they say the survival of the fittest comes along. So, for example, here is a grasshopper, right? Okay, 100,000 years ago, grasshoppers. So I'm making this up, by the way. 100,000 years ago, grasshoppers, they had half the size of legs that they do now. Okay, they just had little short, little stumpy legs, and then they kept getting eaten by predators that eat grasshoppers. Slowly and steadily, for some reason, and they won't explain what the reason is, it will just be nature selected it to happen. So we'll use those terms for the time being. Nature selected it, that grasshoppers' genes mutated, adapted, and their legs got a bit longer and longer. Why? To adapt to the predatory culture that they had to get away from. And because they survived longer, these grasshoppers, and they mated more, eventually over a long period of time, grasshoppers then, in general, took on the characteristics of long legs. The fittest survived. Okay, so that's really how the story goes in terms of all living creatures. Sometimes these changes, they say, leads to microevolution. That is, changes and within the same species. So here is a butterfly with brilliantly white wings because it's in some place where white and light colors are dominant. But then something changes in the environment, and the environment becomes a bit dark. The grass becomes greener and the rocks become darker or whatever. And now they can be seen by any predator, because they're standing out and they get eaten or killed or whatever. And so natural selection and genetic mutation kicks in, and they somehow adapt to their environment and they become dark in color. We see this actually happening, okay? That's called small scale evolution. And we normally refer to it as adapting. And we do that with cats and dogs, right, as well. We might breed certain cats to get certain traits out of a cat, or certain dogs to, and that's kind of, that kind of inbreeding or breeding, crossbreeding is a form of adaptation. Then there is the one that kind of puts religious people's heads in a spin. Other times they say the changes are macroevolution. They're changes on a significant scale whereby new species occur. One creature over millions of years gradually changes into an entirely different creature. So here's this fish. Over millions of years, it becomes a land reptile. And the next few million years, it turns into a horse, right? They call that macroevolution. And in the language of in the language of evolution, they call that speciation, changing from one clear species to another entirely different species through, and there is some discussion here about gradualism and whatever, but let's take that standard thing, through gradual change. How gradual? They're not clear, okay, but gradual change. So it's not like 1 minute it was a fish and then the next minute it was a horse. It's unlikely to be that. It's likely to be transitions. That's really the story. And they say the mechanism which drives this change is not God, not something supernatural. It's natural selection, the environment, and random genetic mutation. If you were to ask them, what is natural selection? Don't ask that question. It's a taboo question because it doesn't have an answer. What does it mean, random genetic mutation? Because you're suggesting that this natural selection and random genetic mutation, that they seem to have an idea of what they need to be doing with creatures to help them live. No, it's all very, it's all very unconscious processes, natural selection. And it's something, it's one of the big criticisms against evolution. Natural selection, why don't, the religious person will say, why not say God? Random genetic mutations, why not say God? But nonetheless, God is out of the equation according to them. Natural selection, random genetic mutation. And as I'm sure you're aware, Rami, we can do good science, astrophysics, biology, chemistry, you name it, without necessarily having to bring Allah into the equation, in the sense that I know that could sound disrespectful as a Muslim. Of course, for us, Allah is at the center, at the heart of everything. We don't even blink. An atom, a subatomic particle, doesn't even decay or come into existence except with the will and the creative act of God. There is no might nor power except with God, and we take that at its face value. Absolutely, God is in control of all these. I mean, billions is short, billions and billions and billions of atoms in the whole of the cosmos, and all the subatomic particles, and even the subatomic particles within those subatomic particles. God is creating and destroying, organizing all of that. And if we say, oh, that's a bit difficult, well, that's why we say Allahu Akbar, because God is great. I mean, there you have it. But we can do science. Like, so for example, an atheist can do just as good chemistry or biology or physics as a theist can, okay, because as long as you follow the rules, that's good science. So yes, in one way, we don't have to bring Allah subhanahu wa ta'ala in the equation, but it does beg the question, what exactly is natural selection? What is genetic mutation? But that's a story. Evolution then says three major things. So if we want to know what the pillars of evolution are, the 5 pillars of Islam, we can say the 3 pillars of evolution, which most evolutionary biologists won't disagree on. They'll say evolution makes claims about 3 different but related things, 3 different but interrelated things. Firstly, that all living organisms are related by common descent, whether it's fish, giraffes, human beings, gorillas, lions, tigers, whatever, buffaloes, boars. Go back long enough and you will find that their family lines merge together, and then those family lines merge together right back to one thing in the primordial soup. That's really what they say. And the second thing they say is that we can now say, especially with genetics and DNA, when living organisms split off from each other, when quote unquote human beings split off from the great apes, when hyenas split off from dogs, we can tell you exactly when that happened and what changes occurred at that point, because we do that through DNA and DNA sequencing. And the third thing is, we can tell you the mechanism by which evolution takes place: natural selection, random genetic mutation. As regards to the first thing, organisms are related by common descent. If we were to use an Islamic term, we would say that scientists call that qat'i, definitive, absolutely true. As far as they're concerned, it's absolutely proven beyond a shadow of a doubt. Any new discovery won't change that. It will only enhance what is already there. That's another point to bear in mind. We do rightly say science evolves and changes. Yeah, but that doesn't mean we Muslims have got to, well, we human beings have got to understand that doesn't necessarily mean that whatever science said before, the new science will completely wipe out the old science. In some cases, it might. In other cases, it won't wipe it out. It will just fine tune it. Okay, so for example, relativity, Einstein's theory of relativity didn't wipe out Newton's ideas. It refined it, gave it high definition, and then it applied it to places that Newton's mechanic couldn't be applied to. Okay, but apparently, if they find certain subatomic particles, that will literally wipe out the existing standard model, they say. Okay, this is what they're saying. So sometimes when science discovers something new, it wipes out what came before. And at other times, it doesn't wipe it out, it enhances it. This is one of the things they say it won't wipe out because it's so clear-cut. How do I know it's clear-cut? I don't. I am actually just following those who I trust. Can I be in a position as a Muslim to say, it's not clear-cut? No, because I could be lying. If I don't have the specific knowledge, I shouldn't be talking about things I don't have the knowledge on. All I can say is, according to these experts, this is what they say. But they need to be experts. Also, when lineage split from each other, the DNA sequencing, especially in the last 10 years, is pretty incredible. I have a friend she works in DNA sequencing. She did her PhD in it, and now she works for some company. So I remember going through this with her and whatever, and I realized that it's gone on leaps and bounds. And there are some things in evolution which are, so now we can say there are some things in evolution which are factual. There are some things in evolution which are likely to be true, but they still need a little bit more testing. There are some things in evolution which are probable. Maybe it is right, maybe it isn't. Time will tell, evidences will tell. And there are some things in evolution which are purely speculative. I mean, it's just like the scientist, she was sitting there one day, or he was sitting there one day, and just thought, oh, what about this? Maybe this. Yeah, maybe this, but it's just a hunch. Okay. We cannot therefore give one ruling on evolution, given the fact that some things are likely to be factual, some things speculative, some things just a hunch, some things even false. No more than giving a ruling upon the whole of the United States of America. Islamically, is the United States of America, are Americans good people or bad? You're talking about, I don't know, 200 million of you, right? All your, whatever. How are we going to give a single ruling on 200 million people, right? So likewise, when things get complicated, it's difficult to give a single ruling. Generally, our scholars teach us, and I've heard one or two of my teachers over the decades say this: if you see someone give a judgment on a complex matter just as a singular thing, know that that person probably hasn't studied it. I mean, they were talking in context of Islam, but you can expand that. So it doesn't really matter if we don't really fully understand the theory of evolution, but what we're saying is, here is a rough outline of the standard model. This is what one would learn if they went to university or picked up a book on evolution in a popular bookshop. I don't know what your popular bookshops are now, but obviously you have them. That would be the story. changes over time in living organisms, sometimes changing within a species, sometimes changing to a new species through genetic mutation, random genetic changes, natural selection. And it's very difficult to do biology, and it's very difficult for modern biology to make sense outside of the teachings of evolution. It's really difficult, to be honest. Okay. The thing about the standard version of evolution, on the whole, it has a very powerful way of predicting and explaining things. It has a very strong explanation potential.